Hello, everybody. My name is Tomislav.
I'm Milos.
And we are creators of Top 11, one of the most popular online sports game in the world. We are from Nordeus, which is a Belgrade-based company. And today we are going to talk about porting Top 11 to WebGL. This is going to be a retrospective. So why did we port our mobile-first Unity game to the web? Well, we had a Flash version on the web, and this would be an update that would consolidate 3 platforms into a single code base, and we would improve the product for our users and give them new features on the web. We did this by using Unity's new WebGL build target. But first, let's introduce our game a little bit more.
Hello, we are from Nordeus. We were founded in 2010 as an independent gaming company based in Belgrade, Serbia. Now we have more than 160 people, around 3 offices. So headquarters in Belgrade, and game studio in London, and marketing office in Dublin. So our flagship product is Top 11. And Top 11 is one of the most popular online sports games in the world, with over 140 million registered users. And our brand ambassador here, as you can see on the slide and on my t-shirt, is Jose Mourinho, the famous football manager. So when I got to Nordeus back in 2010, we had just Flash version released, and actually the code was real mess. So we decided to rewrite it from the scratch. But at the time I got my kid, so there I was spending long hours at work and those short hours not sleeping at home. But we did it, released it, and in parallel with our team, 2 other teams were doing native Android and iOS applications. So we became one of the first games that provided true cross-platform experience for our users. But after a while, we realized they were spending too much time developing new features on 3 different platforms. So we decided to switch to Unity and to consolidate everything in the single code base. And we did it. And at the time I got my second kid, so like a déjà vu for me. And we did it just for Android and iOS at the time in January 2015, because web technology was in a bit of kind of a transitioning. So I'm talking about web browsers stopped supporting plugins. More precisely, Chrome was stopped supporting all NP API plugins, including Unity Web Player. And Flash was becoming slowly an obsolete technology. So the whole web ecosystem was moving towards HTML5 and underlying technologies, one of them being WebGL, which is actually a JavaScript API that allows users, developers, to create games and render their 2D and 3D graphics content directly on web canvases. Unity was there from the start, following the technology trends and creating their own pipeline that allows Unity developers to release their games on the web using WebGL. So I was quite interested into technology, and I heard a guy from the company doing some experiments in late 2015. And that guy is just next to me now. Tomislav.
Thank you, Mr. Markovic. So my story starts actually here in Amsterdam. I was with a friend from marketing, and it was a nice afternoon. We were relaxing and brainstorming, and he had some data suggesting that engagement of our users would improve tremendously if we gave them new features which were mobile exclusive at the moment, like 2D live match, for example. And the biggest deal would be that our Top 11 product team would have more focus on the product itself if we consolidated all 3 platforms into a single code base. So when I came back to Belgrade inspired, I decided to take a look at Unity's WebGL export. And Unity announced that in 5.3 version that they're going to release in December of 2015, they're going to remove the preview label from the WebGL build export. I took a look at which browsers supported WebGL at the time and estimated the availability at around 85%. So that was OK for us. We decided to gather a team, and we started digging into the beast that is WebGL. So first, we had to figure out how the heck does this work at all. So first, you write your C# code in the editor, and then it gets compiled by the mono compiler to the intermediate language, which is then compiled by the IL2CPP compiler to C++ code. And if you have worked with iOS builds, these three steps should be familiar to you. But in the WebGL, there is another step. The mscripten compiler compiles the C++ code to the asm.js, which is a subset of JavaScript. And at the end, you have these 6 files as the output. You have build.js, which contains the entire source code of your game and the Unity engine source code. You have build.data file, which contains all the assets that are embedded into your application and resources. And the rest of these files are used to initialize the application when you host it on the web server. So we hosted the files, but our game didn't run for very long. Why is that, Mr. Markovic?
Yeah, that's right. Our game actually stopped running even before it started executing, basically. And there are two main reasons and two main challenges for us at the start. And that's JavaScript not supporting multi-threaded code, and also JavaScript not supporting direct access to TCP stack. So we needed to rewrite our COM stack from the scratch, and we had to use WebSocket protocol instead of TCP sockets that we were using. So we ended up with two implementations for COM stack inside of our project. One used for Android and iOS clients that uses TCP sockets, and the other for WebGL that is using WebSockets. We did that by using WebSockets plugin available from Asset Store. But we had to do something on server side also. But instead of doing the same thing with the two COM stacks on server side, we decided for another approach. We decided to introduce the proxy server that is in between WebGL clients and game server infrastructure. And actually, all WebGL clients are speaking just to this proxy server using WebSockets protocol, and that server just translates and forwards messages to appropriate game server using TCP sockets. And we done that because we didn't want to change the existing infrastructure, and we didn't change it at all. And also, so our Android and iOS clients continued speaking with the game servers as they were. And also, our game servers actually didn't realize that there is another proxy server in between clients and servers. Another thing that I mentioned is not that JavaScript doesn't support multi-threaded code, and we've used multi-threaded code just in the old implementation of Communicator. So while writing new one with WebSockets, we used Unity coroutines instead multi-threading, and that's basically our tip to you is to use Unity coroutines, and you in most cases can use them instead of threads. Another thing that we faced from the early start is that build times last too long. Actually, it takes about 20 minutes to build the application size of top 11 is for WebGL. And because everything we did is actually platform specific, we had to build the application in order to check do our changes take effect. So fortunately for us, we had in place already continuous integration system that we had to adapt to handle WebGL builds, and we did that. So we were not blocked anymore while builds were, because builds were running elsewhere, not our development computers. And our advice to you is to use continuous integration system, either implement your own, as we did, and you can check out the blog post at the link here that can help you, or you can use new Unity Cloud Build service for that. And I think since now we have our game running, our fast iterations times, that we can release the game.
Not so fast, Mr. Markovic. You can build a game and you can run it, but it does not run for very long, actually. Here is something very important. When Unity tries to initialize the client, it has to allocate a continuous block of memory for the heap in the browser. So you have an editor setting which controls this. Let's say you put 2 gigabytes into this text field. Then it might work on your browser while developing, but it would maybe crash on somebody's poor single-process 32-bit browser, because the browser would not be able to allocate the continuous chunk of 2 gigabytes, and it would crash the browser with an out-of-memory exception. So then what do? You try with a tighter WebGL memory size. We tried with 256 megabytes in production, but that would work for about 15 minutes for us. That is because problems with memory fragmentation, if you are continuously allocating and deallocating memory, you can actually run out of space after some time. So in the end, we settled with 384 megabytes in production. Fortunately for us, we were porting a game from mobile to the web. So we had experience with those low-level Android phones, which have 256 megabytes of RAM. So our application was already pretty optimized. But the only thing you can do is to mind the memory allocations while developing your game. If you don't know if something's allocating memory, you can check always in the Unity's built-in profiler. So we can play the game for quite a bit. Can we release the game now, Mr. Markovic?
Well, our game actually is running, but its size, it's more than 80 megabytes. So it takes quite some time, actually more than 9 minutes, for our users on low-end networks to download the game.
Is that a problem for us, Mr. Markovic?
Well, I think it is. You see, our users on the web expect to get their content immediately. And when you have game, it's not possible every time. But as developers, we should try to minimize that application size and downloading times as much as we can. So our goal was to decrease size of every file we host to be below 30 megabytes. And why that number? Because we experimentally determined that that is the maximum size of the file that every browser caches. And if browser caches a file a second time, when a user opens your game, every file will be on his computer already. So how we did it? Of course, using Unity asset bundles. But it's not enough just to use asset bundles. If you extract your resources and download them upfront, user still has to wait the same amount of time in order to get all the resources. But what you have to do is to create like features and mechanisms to download the files in the background and let the user play the game while they are downloading. So we did that. We did that for audio files. We did it for fonts. And we did for 3D assets that are used on our stadium screen, and those are probably the heaviest assets we have in the game. So at the end, we managed to decrease the size of the built data file Tomislav just mentioned below 9 megabytes, which is quite awesome for us. So I think we can release it now. Tomislav, what do you think?
Wait a minute, Mr. Markovic. If the initialization times are really that important to our users, then there is one more thing to consider. Actually, when the browser downloads the JavaScript file, it unpacks it and tries to load it into the memory and parse it. And in our case, we have 50 megabytes of minified ASM.js. That's 3.5 million lines of code in our case. So browser tries to load this, and this requires time and memory, and our users have neither. So size does matter for the code. We have a situation where Firefox and the Chrome deal with this code a little bit differently. Chrome is actually a little bit slower, and it has a really, really nasty memory spike during the initialization. It spikes, in our case, to about 1.3 gigabytes, but you should be careful when you profile your game. It might crash your game, so be mindful of it. And the Chrome browser is actually 2 times slower than the Firefox. So when you're profiling, profile with the Chrome. How do we deal with these things, with the size? Well, best tool for dealing with the size is the stripper, the Unity's built-in stripper for the code. So we used Unity's new build report tool in 5.4, which tells you which module uses how much code in the end. So you can see if there are some renegade modules that you can strip away easily. In our case, we had the physics module, which was about 10% of the code size of our game. But we really didn't need all the physics features. We just needed the box colliders and raycasts. So we wrote our own implementation for ray colliders and completely stripped the Unity's physics module. Also, the Unity continues to improve the IL2CPP build sizes all the time. The latest one is in 5.3.5 version. It offers the smallest code size, and that's pretty much it. The tip for me is to always use the latest Unity version in regards to code size. But if you are waiting to release your game sometimes later this year or even next year, there are good news. There is new technology coming. It's called WebAssembly, and it is designed to deal with this problem specifically. This is going to be a binary format that is going to help with loading the code and executing the code faster. The browser vendors are working on it, and hopefully the Unity will implement it later. But one of the biggest culprits for the code size issues was this yellow exclamation mark, which I found in the editor. It was warning me not to use the full exception support when I build the WebGL. So I just switched the full to explicitly thrown exceptions, and the code size went down drastically, and I think this is OK to release now, Mr. Markovic.
I don't think so. Do you remember that after just a few hours of playing the game with your optimization, our game actually started freezing in some random points of time?
Actually, I think I know why this is happening. When you use explicitly thrown exceptions, when a null pointer happens, the game just crashes. So I think the only solution for this would be not to make any bugs in our game.
Are you telling me that you will not create a single bug till the end of your life?
Let me investigate this a little bit deeper for now. So what does this option actually do? In the C#, the beautiful C#, you have this feature when you do something with a null object, an implicit exception is thrown, and then you can catch that exception and deal with it. But there is no such thing in the C++ code. So what does Unity want to do? It wants to inject the null checks in the IL2CPP compiler. In the JavaScript land, it's even worse. So when the interpreter finds a null value, it just keeps on working, and the game explodes somewhere else in the code. So when you select full exception support, the Unity injects some code which helps you deal with this issue. Make sure to check out the IL2CPP internals blog post, which sheds more light on this. And here are the exact flags that get passed to the IL2CPP compiler. When you select explicit exceptions, none of these flags get passed. But when you select full exception support, you get null checks, you get array out-of-bound checks, and you get stack traces, which we found a little bit odd. And then we profiled these flags separately. And here is what we found. Null checks and array out-of-bound checks for our game increased the code size for about 3%. But we were shocked when the stack traces completely destroyed performance of our game. So we actually need an option that is somewhere in the middle, something that just deals with null checks and array out-of-bound checks, but does not use stack traces. It would be cool if Unity added such an option in the meantime, but fortunately there is a workaround. You can do something, and this is completely undocumented, so don't tell anybody about this. And this might change in any version of Unity. But you can do a couple of things to pass additional arguments to the IL2CPP compiler. You can set up an environment variable called IL2CPP additional args and add a string which specifies the additional arguments there. Or you can use the reflection in editor to set a string called additional IL2CPP args to args you want. What we did was something else. We hijacked the IL2CPP exe file. We find it in the data folder of the Unity. We overwrite it with our own IL2CPP exe file, which calls the original IL2CPP with the flags we actually want. This is a good tip if you want to eject some of your custom code into a build step of Unity. This solved all our problems with the stack traces and null pointer exceptions. But unfortunately, we didn't want to pass the stack trace flag to the IL2CPP compiler. So we completely lost the meaningful stack traces. We have implemented the crash reporting tool, and in production, it is a very useful thing to have. But we couldn't have stack traces. Again, the C# follows the code as it's executing, and when something explodes, you know the exact stack trace. C++ does not do this. But JavaScript, thankfully, does this. JavaScript exceptions and stack traces are not going to be identical to your C# code. But they would be good enough and help us deal with some issues in production. The only problem with JavaScript stack traces is that they are minified, and the method names are unreadable to us. But the good thing is that you can pass an argument to the mscripten compiler that will make him create a symbol map that you can use to decipher those obfuscated stack traces from JavaScript. So I think this solved all our technical issues, and we can release the game now.
Well, wait a minute, Tomislav. If we release the game now, that will mean that we'll be releasing some mobile UX on the web, to the web. So I'm not sure, is that a good idea?
I don't think that's a good idea, Mr. Markovic.
Okay, let's organize some user testing and find out what exactly issues we might have. So I think we already have implemented GUI layouts for our tablets for Android and iOS. So we can use them for our WebGL version and find out, do users have some problems with it? And it turned out that tablet layout for GUI works quite well for us on WebGL also. And our tip to you is to mind if you are dealing with one application that is meant to be for mobile and for desktops or WebGL. Be careful about those small UX issues that you might have. And user testing that we did, in our case, showed us a few different things. So we changed this navigation menu from the one that slides in, that's pretty typical for mobiles, to always accessible navigation on the left side of the screen for WebGL. And also, we've changed how user navigates inside one screen. So we changed swipe gesture with standard tabs and just clicking on the buttons that are above it. But probably one of the most important things that our users were missing was missing tooltips. And these are these small balloons that we show to the users when they hover a mouse over an item. And these are quite important for our game, because we have a lot of data and a lot of GUI, and users can access some additional information through that feature quite easily. So we implemented the tooltips mechanism in the core of our GUI system, and it's pretty much solved all our problems. But I've noticed one more thing, and that is that we are missing labels here and there. Do you know about that?
I think I know what's the problem with this, Mr. Markovic. Yeah, well, you see, one of the big drivers for the success of our product is that it is localized in over 30 languages, which is awesome for our users. But be aware, on the WebGL, there is one technical issue. You cannot access the system fonts directly from JavaScript. So in order to be able to display Japanese, Chinese, Korean, you have to embed all the TTF fonts into your application. But as we said before, we don't want our initial download size to be too big. So we just created a system that downloads the font in the runtime. Only the user's language is downloaded up front, while the rest fonts are downloaded on demand in the background. So here are your labels, Mr. Markovic. Can we prepare the release now?
Yes, please. So what we actually can do is to measure how many users, our actual users, can load the WebGL content by releasing WebGL compatibility check method inside the old version, next to the Flash application that we already have. And we did that, and that showed us that around 78% of our users can load WebGL content in their browsers they were using. So that somewhat differs from that Tomislav's estimation from the start that 85% can play new game, because you see, not if a user has the latest browser that supports WebGL, if he also have like old computer and his GPU and the GPU drivers are not supported by WebGL, he also cannot play the game, and we didn't have that information before we released actual check into the wild. One more thing that we did is we checked browser compatibilities by our own. So we checked all different versions of browsers and checked how our game behaves in different browsers, and found out that even some browser versions officially support WebGL content. Our game actually was running very badly, not smoothly in them. So we explicitly blacklisted some of browsers versions. And if anything of these things goes wrong, we automatically redirect users to the old Flash version that we were keeping alive for, and we are still doing that for a time. So my tip to you is check how your users behave, whether they have, how much of your users have WebGL issues, if you can. But if you cannot do that, there is website, webglstats.com, where you can like see global data and how many users there are and on the average. What we also did is some more JavaScript work outside of the Unity. Fortunately, Unity allows us to do so in quite easy way. And that is by using one of these two methods inside of Unity that just calls external JavaScript code. And we did that. We implemented such JavaScript for our payment providers, because in the old Flash version, we already had implemented payment providers outside of the Flash application, outside of the game. So we made it easy on ourselves and used the same thing, just adopted to work with new WebGL version of the game. And also, we've done JavaScript work for tracking our analytics and our crash reporting, because we wanted to uniform the code to have single code that tracks both things for the purposes of JavaScript, our Canvas project, and our game. And in this moment, I want to give you an advice not to make the same mistake as we did. From the start, we gathered a team of Unity and C# experts without much knowledge of web technologies. But you see, every time you build Unity WebGL game, you get JavaScript code, and you have to deal with JavaScript stack traces, JavaScript exceptions, with tools that measure performance, and those are, of course, web tools. So it would be much more easier for us if we had web stack expertise right next to us, or to have it by our own. So, and we will be quite faster and deal with some issues up front. So I think that's pretty much it. I think we can release the game.
Let's do it.
Yeah. So we released the game.
So how did it go, Mr. Markovic?
Well, actually, it went quite okay. There were a few issues, and one of the things that surprised us the most was that actually only 62% of our users play the new WebGL version, and the rest of them is still playing the old Flash version. And that's like pretty lower than what our WebGL compatibility check is still telling us. So we analyzed the data, we thought about it, and we realized that there are two main reasons for that difference. And about half of the users in that difference use the Flash version because they simply don't like change, and they like to use familiar stuff. And the other half have some technical difficulties. For example, when they select specific options in the browser settings, the game may crash. And Unity is dealing with these issues, and also browser developers. So Tomislav mentioned earlier that you should use latest versions, and it pretty much solves the most of the stuff. And also, these differences because some users have pretty low RAM, so our game runs pretty badly below 2 gigabytes of RAM on computers that have less than 2 gigabytes of RAM. And that are the reasons why number of our daily active users on the web dropped by about 20%. But those users were mostly low active and non-paying users. So actually we have more users, more payers on the new WebGL version than on Flash. And since we released new product, better product, new features, our revenue actually increased for about 30%. So we achieved our goal.
So we did it. We did it in 2.5 months with a team of 6 people using the new Unity WebGL export, which is stable now, and all the little problems are sorted out. It's always getting improved, and this year is also going to be big for the WebGL because the WebAssembly technology will come here. We successfully consolidated 3 platforms into a single code base, which was the biggest win for us. We made our users happy with the new features and made our product better, which in turn increased our revenues. So I think the WebGL technology is here. There are users. There are going to be even more games. And today we spoke about the challenges we had and hopefully shed some light on this topic for you and made something easier for you.